Okay, students, let's start the module 13 lecture, which is ICMP messages. ICMP messages is actually your echo messages that you send in the form of ping, okay? So your internet control message protocol, it tells you information about processing of IP packets, okay? It tells you messages about whether you can reach a certain host. It can also give you information with regards to how many hops you can travel if you are going to a certain destination, okay? So we have got a certain commands associated with your internet control message protocol. And one of those is your ping command, okay? ICMP is common to both IP version 4 and IP version 6. That is why right from the first session which we had in CCNA-1, we started using ping, okay? And both of them will tell you whether you can access a certain host or whether that host cannot be accessed. And if you cannot access a host within a certain time, it will also tell you that, okay? And you can also disable your ICMP messages if you want, okay? You know, by default, all our computers have got their Windows firewall enabled. So if you ping and you do not get a reply, it doesn't mean that the network is not working. Perhaps the firewall of the host is enabled, as I will show you later if you have time, okay? So example is this device will send a ping, okay, to another device and see whether it's accessible, okay? Now, in order to send to another subnet, you see, you have to go through a gateway here, through another subnet, through this gateway, to another subnet, and see whether you can access it. If you can access it, the equal reply will be yes, it is reachable. Okay? And we can achieve this miracle by using ping. Okay? We've got a message from Hamza, note from Osama. I'm currently at the airport flying to Qatar. I will be present for classes from next week. Okay. Okay, have a safe trip. Okay. We can't have a session without Sam coming in and telling us something, okay? No more deleting any segment, my dear students. That segment itself, deleting it, I had to wait for editing the video for a long time. No more editing. Just continue with what we have, okay? No time to edit. Yes. Okay. There are certain codes with regards to your ICMP messages for version 4 and version 6. For example, 0 means not reachable. Net is unreachable. 1 means host unreachable. 2 means protocol unreachable. 3 is port unreachable. Similarly, you have got certain codes with respect to IP version 6. Okay, so these codes have got a special meaning. And besides that, your ICMP has also got a time exceeded field. Okay, we studied this in the lecture if you remember. Okay, in lecture we studied it to be a TTL, time to live field in a packet. Okay, And every time it is given a particular value and it keeps decrementing. And when it comes to 0, that means a time exceeded message will be sent to the host. Okay, that for example, it could not find it. Okay, here for example, they are pinging 8.8.8.8. Okay, and here, there, you get a reply and nothing is lost. Okay, 8.8.8.8 is the primary DNS server for Google DNS, if I'm not mistaken. Okay, let's try it. Yeah, what I do is ping 8.8.8.8. There. I could ping my primary DNS server at Google. Okay, ping www.google.com. Yes, perfect. There, I got the IP address as well. Okay. Your ICMP version 6 has certain new features. Okay, as we discussed. That's why topic number 13 we are covering along with topic number 12 because there are some similarities. Okay, so between a router, IP version 6 router interface and IP version 6 host interface, what we have is a router solicitation message, which the host will look for a router in order to get an IP address, and a router advertisement message, which the router will send to the host. The host also can communicate with other hosts or other interfaces by sending a NS, which is neighbor solicitation message. And other devices or even a router interface can communicate with that host by giving a neighbor advertisement message. There are certain reasons why they have to communicate for this. Let's have a look. For example, over here, your host will send a router solicitation message. Okay, and then the router will send, okay, this is my RA message, router advertisement. It tells the device what is the IP address, IP version 6 address, what is the network portion, what is the subnet, and what IP address can it get automatically. From where does it get the IP address automatically? Is there a Slack device or is there a DHCP device and so on? Okay, as we studied just a few minutes ago. Yes, as we studied earlier, your router will send a router your PC, your host, a device, shouldn't say PC, a device will send a router solicitation message, and in response to the router solicitation message, your router will send a router advertisement message. Okay, and based on that, it will refer to a Slack server or a Slack device or a DHCP server and assign an IP address to the device which has sent the RS. Sometimes your devices may also communicate with other devices in the network, okay, in order to do something known as DAD, which is duplicate address detection, to make sure that the address that is given to it is not a duplicate. Okay. In those situations, the host will send a neighbor solicitation message to check whether the neighbor IP version 6 address is not the same as what it has. Okay. For example, the router also, remember the router needs to have the MAC address of all the devices. In those situations, even the router can send a neighbor solicitation message, okay, and get the neighbor advertisement, get the device to send a neighbor advertisement so that it can get the MAC address of this device in its table. Okay. Yes, like I said, in order to find the router's table should filled up with all the MAC addresses of its network. So it also can send a neighbor solicitation message, and the PC will send a neighbor advertisement message and say, hey, this is my MAC address. Okay. Now, when we come to ICMP, two main commands from ICMP is ping, which we have been using for a long time, as well as traceroute. Okay. Ping is a command that you have been using since the beginning of this unit to find out whether you can reach a network. Okay. We have got, in order to check your IP version 4 TCP, whether it's working, or IP version 6 TCP, all you have to do is ping your loopback address. Like I said, ping : 1, my IP version 6, working. Okay. My IP version 4, ping 127, sorry, dot 0.0.1, working. Okay, so my TCP IP is perfect and it's working, no issues. Okay. You can also use your ping to successfully find out whether you can access a device. Okay. Whenever you do a ping, you are sending an echo request, and if you get the echo reply, that means the network is perfect. Over here, my IP address is 10.0.0.1. My gateway is G000, which is 10.0.0.254, which I've given over here. Okay, so I should be able to ping with all the local devices over here. And I can also even ping to devices out. Okay, this one is IP version 4. Okay, so in IP version 4, you don't have to configure the router specifically. But for IP version 6, as I showed you, you have to just go to conft and type IP version 6 unicast-routing, and then you can ping. Okay. You can ping from one device to another device as long as you have set the routing table. Okay. As long as you have said that, hey, for this device, this is the gateway. For this device, this is the gateway. And if the routing is enabled, then you can ping each other. In cases when you have got, in cases where you have got a firewall, then you cannot even ping within the same network, much less within another subnet. Okay. Let's have a look. I'll give you an idea. Open Cisco Packet Tracer. What I do, I just have two devices within the same network. Okay. Two devices, PC to PC, remember, it should be crossover. Okay. Let's do a basic IP version for 192.168.1.1. Okay. No need for a gateway. We don't have a router here. It's just a local connection, small network. And this one will be 192.168.1.2. Okay. So pinging, okay, ping 192.168.1.2. So ping PC1 and successful. Same goes for pinging PC0, ping 192.168.1.1. Okay, and ping is successful. Now let's go and play around with this. Yeah, here you see. Let's have an IPv4 firewall. Okay, interface on fast Ethernet 0. Action deny. Deny ping is ICMP. Okay, deny ICMP. Okay, which IP address? Let's say I want to deny PC0 to access. So 192.168.1.1. Okay, wildcard mask is something you will study in CCNA version 3. Okay, sorry, CCNA 3. The version is version 7. Sorry, CCNA 3. You will learn about the mask. So here the mask will be, if I'm not mistaken, 0.0.255. Okay, so there. Once I add it, okay, and save, now even you cannot, even the network is perfect, you can never ping PC0. PC0 cannot ping you. Okay, so let's try again. Let's try again. There we go. This was the command. You see, previously I could ping. Let's see whether I can ping PC1 now. I can still ping. Let's go and check. Firewall. Okay. Service on. You see, my firewall was off. Now you switch it on. Okay. Let's try. Let's try again. Okay. Now try again. Ping. There. Cannot. Okay. Because your firewall is on and you have specifically denied that PC to access it. The same goes for this. Now you cannot even ping your PC1. You see, previously we could ping. Now we won't be able to ping. Okay. Even ICMP messages can be denied to access each other. Okay. Another ICMP command that you can try is your traceroute, which will tell you the route it takes to access. We have seen this before, if you remember. Okay, the route it takes to access a device or a network. Okay, if it can access the device, okay, every time you send it, it will have a time to live field value of 1. Okay, and progressively from there, that's so you first hop, second hop, it will just increase by incrementing it, okay, until it reaches that actual field. Okay, let's try this as well. I'll try it on my actual computer. Okay, so what I do is I type Traceroute. Let's see how many PCs does it, how many hops to google.com. It also says that sometimes if it cannot access, you see the previous one, if it fails to respond from one router, you will get an asterisk. Okay, so let's see, in order to access google.com from this PC that I'm talking to you with, how many hops it takes. 1 second. Oh, you see, there, cannot access. Okay. Okay, another 4th, 5th, 6th, 7th, 8th, 9th. Okay, trace complete. Okay, so whenever I go to Google, I have to go through 9 hops. From my ISP, to Google. Okay, you can do the same thing on your computer to find out how many hops to reach your Google router. Okay, this is actually very powerful commands, my dear students. There's so many other commands that enable you. If you study cybersecurity, you will learn so many things, okay, which even enables a person to do damage. Okay, so that brings us to the end of ICMP. Anyone has any questions with regards to ICMP? Okay, I'm going to stop the recording.